Hi all, probably time for some introductions. Here I am in the middle, Qbot. Glad to see you all again. To my right you have KV, and on the left, don't know what the sheep's called yet. Maybe you can come up with some ideas. Today we're going to do a little session on isometric sketching. It's going to involve the trusty hands to show us what to do. And by the end, with any luck, you should all be confident and happy that you can produce three-dimensional drawings of all your favourite objects. So not all of these sessions in Sherlocks workshop are going to be about learning how to do stuff specifically, but I just thought I'd kick off with isometric drawing because that was the Year 8 homework task last week, and there's a development of it coming up next week as well. So any of you who are still stuck, this might help you. So isometric sketching is a way of drawing in 3D that recognizes that there's a slight optical illusion when we look at objects, and it is this. So if we look at the telephone here, you'll see that as we can see it, it looks as if the corner that is nearest us, this one, is lower down than the two corners on either side of it. And if we were looking at a real telephone, we could prove this by putting a ruler across it there, across our line of sight, and we'd see that the corner here would be obscured. Now, you know, it is only an optical illusion, but nonetheless it's one that we've got to try and capture in our drawing. So let's have a go at drawing a simple cube like Year 8s were asked to do in their homework task. So here we go. So we'll start by positioning that corner that is nearest to us and therefore must be lower than the corners either side. Then we can draw a line running away from that corner to the corners either side of it, like so. And then we can start to fill in some of the vertical lines. Okay, just like so. And then we can fill the top of the box in like that. Okay, fairly straightforward, jolly good. So let's look at that in a bit more technical detail. Okay, so the standard way of drawing an isometric drawing is for horizontal lines to be at 30 degrees to the horizontal in your drawing. So I'm going to set myself a baseline here. There you go, here's my baseline. And now using the 30 degree angle corner of a 30, 60, 90 set square, I can set my angle. So there's one side. And here's the other. Oh, excuse me, KV, you just got smashed. So here's my two lines. They're going to intersect somewhere around about here. There you go. So now I can draw my cube based on that. Okay, 30 degrees. Now, some of you may have used isometric grid paper to do this kind of thing. It's the stuff that looks roughly duffly like this, etc. And that's okay, but there's a couple of things I don't like about isometric grid paper. One is that it gives you very, very sort of boring, defined drawings with every angle is perfect, and they just look like dead objects. They don't really look like they're alive. The other is it's a bit like learning to ride a bike with stabilizers, or learning to ski in a snowplow, is that the next thing you need to do is to learn to ride a bike properly or learn to ski properly, because you're never going to use those stabilizers or snowplow again. So let's go back to the step by step. So step by step, start with the point that is nearest you and is therefore lowest. Okay, maybe give yourself an imaginary horizontal line, and then remember that any line that is horizontal in real life, in other words the bottom of the box, is shown at 30 degrees to the horizontal in your drawing. So there's my two lines running away from that corner. That any line that is vertical in real life is going to be vertical in your drawing. Here we go. And there's a third rule that helps, which is that any lines that are parallel in real life are still going to be parallel in your drawing. So this one and this one are parallel. This one and this one are parallel. this one and this one are parallel, and this one and this one are parallel. Once again, there's our box. So the next thing the homework task asked you to do was to cut some holes in the box as well. So here we go. Let's cut a hole in the box here, square hole. We'd obviously see the thickness of the material of the box. There you go. There's a hole cut in there. Let's do a circle in here. Now circles are in isometric view are always ellipses, looking roughly like that. Thickness of the box visible there. And cut a triangle in the side. There you go. Probably see the thickness of the box there, wouldn't we? Now we can ask ourselves all sorts of questions about what we'd see through these holes. But let's not go that far at this point. All right. So the next part of the task was all about a technique called crating. And think about crating, you just need to think about a crate or box that your product or component is held in. So if we were to think about how would we draw an isometric view of the triangle, we can start of a triangle that would go through that hole in the box. We can start by imagining the triangle in a box itself. So here's the front view of the triangle in the box. Okay. Now, we don't know if we can't necessarily draw an isometric view of the triangle, but I bet we can draw an isometric view of the box because it looks like this. Vertical, horizontal, horizontal, allowing for the thickness of the triangle. Here we go. Still completing the face of the box, now the top of the box. There we go. And now what we can do is map some points across. So we can see that that point must be there, that point must be there, and this one is probably in the middle of this face here, isn't it? So now I can join those up to create the isometric view of the face of the triangle, and then I need to add some thickness in. There you go, join those up. There's my triangle. Obviously I can rub out my construction lines now. Here you go, isometric view of a triangle, triangular prism even. Now with crating, of course, we can start to develop some isometric views of rather more complex shapes. So here's a good one to practice on is capital letters. So here's the first letter of my name. Yeah, that's a reasonable M. Okay, isometric box, start with the corner at the bottom, lines running away at 30 degrees, vertical. You can see I'm starting to get a bit slapdash and less perfect, if that's possible. Okay, again, mapping points across, we've got some obvious ones, there, and there. These I'm going to put evenly spaced along there, that one's somewhere in the middle, let's say about there. These four, well, we've got to have some legs, then we've got to have some points at the top of those legs. Going to be directly above them. Just check those are still on that 30 degrees from the horizontal line. That's going to be like that. Okay, and then we can start joining the dots. Etc, etc. Okay, always remembering to check how much of the backsides of the component you'll be able to see. There you go, letter M. So the last one before we attempt some kind of review is what do we do about curvy shapes, because they are a little bit trickier than straight lines, but we can use the same sort of approach. So let's try this time. I'm going to draw the front of my box, and inside this box is going to be a capital letter C, I think. So there we go, all the way around. Oops. If I was any kind of graphic designer, I'd be able to tell you what typeface this is, but if I was any kind of graphic designer, it wouldn't look so wobbly. Right, so here's my box, what it lives in. La 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 la. And again, mapping the points. You have to imagine where those are going, something like that. And then that's going to go all the way around to there. That goes all the way around to there. Now, in terms of the thickness, we haven't got any obvious corners, but if we imagine that the line that goes from here to this point on the back of the C must be parallel to and the same length as that one, then what we can do is imagine, well, what happens as we pan that around the shape? Yeah, so all the way around here you can see that we're going to see the full length of it, and then as it comes back here it's going to start disappearing again until the vanishing point somewhere around about here. So it's going to be like this, okay, and similarly there'll be another vanishing point somewhere around about here, and then here we'd see full width and a bit of thickness, and here we'd probably see, yeah, because it's, if I take a line parallel to that, look, I can see it there as well, and that's probably, I don't know, probably wouldn't see anything there. Okay, isometric view of a capital letter C. Well done. Okay team, so what did we learn? Well, we learned that A, it's probably a lot easier than most people make it out to be, and to summarise, in your drawing, all vertical lines stay vertical. Lines that are horizontal in real life are shown at 30 degrees to the horizontal in your drawing. Lines that are parallel in real life must be parallel in the drawing. And remember to use crating for more complex shapes. Okay, that's it for now. Off to morning break. Of course, the other way to do it is to use computer-aided design. I don't know how well this is going to work, but let's have a go. I'll put some music along in the background so you don't have to listen to me yakking on.